In this lecture, we are going to discuss about the timing and control unit. The timing and control unit in 8085 is used for generation of timing signals and the signals of control. All the operations and functions, both interior and exterior of the microprocessor, are controlled by this unit. We have two pins X2 and clock output pins to do rather perform the operations of the timing in the microcomputer system. We have the generator called as clock generator in CU of 8085. Other than the quartz crystal, the complete circuit of the oscillator is within the chip. The two pins, namely X1 and X2, are taken out from the chip to give the connection of the crystal externally. We connect a capacitor of 20 Faraday between the terminal X2 and ground just to analyze if the crystal is getting started. The frequency of the crystal is divided by 2, which divides the counter of this unit of control by 2. Internally, 8085 works with the frequency of 3 MHz and with the clock frequency. Hence, the crystal of the frequency is 6 MHz. Crystal gets connected between the X1 and X2. Every operation of the entire 8085 system occurs within the given synchronization process. There are peripheral chips like 8251 USART, which does not operate until the small clock signal is in need. And we have a LC tuned circuit that is connected between the X1 and X2. In some systems carrying low cost, a resistor gets connected between the X1 and X2, and the capacitor between the X1 and the ground for the generations of number of oscillations. And moreover, to get a very good stability, we prefer to use quartz crystal. With the internal frequency to be 3 MHz, the period of clock should be 333 nanoseconds. Moreover, the 8085 clock strikes once in every 333 nanoseconds, but our watch strikes once in a second. The cycle of the clock of 8085 microprocessor is termed as T state, where the T stands for timing. The minimum frequency required for the operation of 8085 internally is 500 kHz, that is 1 MHz. But the point to be noted that lower frequency, every information from the register gets lost. It is so since the registers are dynamic in nature and are the cells of random access memory which are to be refreshed in a continuous manner. And status signals, that is input output of memory S1, S0, we require 5 machine cycles to carry the operation procedure. Specific operations are performed by each machine cycle, like reading and writing from memory. A particular machine cycle needs a fixed cycles of clock. The minimum is 3 for the particular clock. The call for the first clock cycle is as T1 and the second is to be T2, and here the period of time is T. The status signals input or output of memory describe the state of the machine cycles where the 8085 microprocessor executes. And here we have the status signals getting emitted by 8085 processor during the T1 phase of the first machine cycle. And here in this table column you can recognize as when the input and status signals conditions, it depends upon the machine cycles. Like if the input output memory is 0, S1 is 0, if S0 is 1, then the machine cycle is ready for the memory write. And for the condition 0, 1, 0, the memory is ready for reading. And for the condition 0, 1, 1, the opcode is fetched. And for the address 101, it is input output write, and 110, it is input output read, and for 111, it stands for the interrupt acknowledgement. So finally, the timing and control signals, we can describe it as a X1, X0 crystal generator, and the total frequency needed for the 8085, and what is the frequency the crystal is giving for 8085, and depending upon the status signals, the memory input and S0 and S1, what is the machine cycle and what is the 8085 is doing on each state, we can we have discussed here. So in the next lecture we can discuss about the interrupt pins and the instruction formats we used to write the program for the 8085. Thank you.